Hello friends, here in this video we are going to see a problem on section of a square pyramid. For that, here we have a question. It is given that a square pyramid, side of base 40 mm and 65 mm height, stands vertically on HP with a pair of its triangular faces perpendicular to VP. It is cut by an AIP, which is auxiliary inclined plane, in such a way that the true shape of the section is a trapezium whose parallel sides measures 40 mm and 20 mm. Draw front view, sectional top view and true shape of the section. So this is the question in front of us. By reading it, we understood that the type of solid is the square pyramid. I'll draw the diagram for that. So here we have a square pyramid in which we have a square base having 4 sides. Then it has 4 corners, and those corners are connected to a common apex point O. Then these corners are connected to the apex with the help of slant edges. And with the help of these slant edges, since it is a square pyramid, we are having 4 triangular faces. So these are the triangular faces. Now I'll read the question what is given. A square pyramid, side of base 40 mm and 65 mm height, stands vertically on HP. It means it is kept in this way, like I have drawn the diagram. We can assume that this is an HP or a ground in which the pyramid is being kept. So when we are looking from top, we are going to see the square base. Now how to draw that square base? The condition is with a pair of its triangular faces perpendicular to VP. So this condition I'll explain by drawing it. So let us get started with the solution. The side of the square pyramid is of 40 mm. Drawing a light horizontal line, marking 40 mm over it. taking this 40 mm, measuring it on one side, similarly onto the other side. Joining the opposite corners. Here I'll give the notations. We have point 1, 2, 3 and 4, and here is the apex. So this is the top view. Projecting the front view, height is 65 mm. O dash, here we have 1 dash, 2 dash, this is 3 dash, 4 dash. Now in the question it is given that square pyramid, side of base 40 mm, 65 mm height, stands vertically on HP with a pair of its triangular faces perpendicular to VP. So two triangular faces should be perpendicular. Now what are those triangular faces? They are triangular face 1, 2 and 3, 4. These two triangular faces are perpendicular to VP, whereas the triangular face 1, 4 and 2, 3 are parallel to VP. Next, it is cut by an AIP, auxiliary inclined plane, in such a way that the true shape of the section is a trapezium whose parallel sides measure 40 mm and 20 mm. So draw front view, sectional top view and true shape of the section. It means it is given that the true shape is there with us, and with the help of that we have to show the cutting plane. So here, first of all, through the apex I will draw a light horizontal line. Trapezium is having 40 mm parallel side and 20 mm parallel side. 40 and 20 both are parallel to each other. Next, since here already we have this side as 40 mm, I'll mark it, give the dimensions to it so that we can understand. So this is 40 mm, means one side of the trapezium we already have. Now we want the other side. So for this, I'll draw a light vertical line. Mm side, projecting it back, and so suppose I get it at 1 and 2. Next I want the other side is 20, so even 20 will be measured over this, taking 10 mm on both sides from the center. So this gives me 20. Now this will be projected back again. So this is the 20 mm side, and for that where this horizontal line is cutting point, you can say edge O24 and O23, I'll mark those 2 points and joining them with 1 and 2 respectively. So here I am getting the trapezium in the top view of 20 and 40 mm parallel sides respectively. Next, it means one end of the cutting plane is here, and for the other end I need to project this vertical line up to edges 3 and 4. So projecting them. Now this will be the cutting plane length. Next I'll draw the cutting plane here. And in the top view, whatever is visible, that will be made dark. Next, when we are looking from top, point 4 up till here, that will be visible because it is the slant edge of the pyramid. 1 to 4 will be visible. Next 2 to 3 will be visible. 3 to 4 will be visible because they are the outlines, and then the slant edge will be visible. So this is the cut portion. Next, when we are looking from top, this portion has to be removed at the top because observer is here. So this top portion is removed and bottom is retained. Whatever is retained, that I'll make it dark. Then giving the notations to it, where it is cutting, that is cutting plane is cutting the edge 1 dash 2 dash, I'll give the notation as A dash and B dash. So here we have point A and B. Then where it is cutting 3 and 4, that is C dash, D dash. So C and D. Then after this, drawing the section lines through it, inclined at 45 degree. So this is the sectional top view. We had to draw the front view, sectional top view. So front view is done, sectional top view is done. Cutting plane A dash. Next, I have to draw the true shape of the section, and for that I will have to draw the true shape in the HP because the section is here, and make this cutting plane parallel to XY in VP. So drawing a light horizontal line here. Now this vertical line which I have taken previously as 40 mm will be projected up, and that will be point A dash B dash, or here I'll say A double dash B double dash for us. Measuring the length of the cutting plane from this corner up till C dash D dash, plotting it here, cutting this horizontal line with an arc. So here we have C double dash D double dash. Projecting light. Next, here we have C. So point C will be projected. Similarly, D will be projected. Here is point A, B. point C and point D, joining them in the proper sequence. A to B connected. Next B to C will be connected. C to D, and finally A to D will be connected. Then drawing section lines through it. So here I am drawing the section lines inclined at 45 degree onto the true shape of the section. Making the section plane dark. Viewing direction. Section plane AA dash. Next, the true shape, they had given the dimensions for that. So A to B is 40 mm and C to D 20 mm, parallel sides of the trapezium. (40 mm). Then the height of this pyramid 65 mm. This is true shape of the section, and with this we complete the problem.